Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a student question. Here we have two sequences. A sequence is just a collection of terms, and the T collection looks like this. And this is, we'll discuss this in more depth in a minute, but this is linear. The P sub n, is a little hard to understand from the way the text came out. So what I'm going to do is we'll just take advantage of some colors here, and I'll use green for the T's, and then we'll use a different color for the P's. So let's begin by just writing it. So T sub n is equal to 4 plus n minus 1 times 7. You should recognize this as being an arithmetic sequence. And you can tell it's arithmetic partly because it's linear. And this, if we were to graph this and we were to look at, here's T sub n here, and n, when n is, there might be a 0, but we're going to just start n at 1 here. We're going to start our graph at 1. Sometimes they want you to start at 0, sometimes at 1. It doesn't make any difference. 2, 3. So let's just plug this in. So T sub 1 is going to be 4 plus 1 minus 1 times 7. So this is going to be 4. And T sub 2 is going to be 4 plus 2 minus 1 times 7. So that's going to be 11. And T sub 3 is 4 plus 14. So that's going to be 18. You can see that every time the value of T is going up by 7, you can think of this as a slope of 7. But basically, you're just going to have something that looks like this. It's going to be a straight line. It's a linear relationship between n and t. Now, the second one is geometric, and you can tell because it's not linear. Let me change colors here, because this one, unfortunately, didn't come out very well. P sub n is 4 times 2 to the n minus 1 power. P sub 1 is 4 times 1, which is 4. P sub 2 is 4 times 2, which is 8. P sub 3 is 4 times 4, which is 16. Okay, another way to recognize the geometric sequence is that each increase is multiplied. So it's every time here you see it's times 2, times 2, times 2. That's called the common ratio, which is R in this equation. It's 2. Up here you see the values are changing by the same amount. So going back to this one, this is plus 3, you see. Plus 3, that's called the common difference. And so that's the characteristic of an arithmetic sequence, is that you have a common difference. A characteristic of the geometric sequence is that you have a common ratio. If we were to plot the blue line, the first one would be 4, so it actually starts at the same point here. And then the next one is 8. The second one was 11, so it's 8 here. It's going to be a little below. And then the next one is 16, which is still a little bit below, but this is gonna go. If I maybe plot another point here, P4 is going to be 32, which is going to be way beyond this. T4 is going to be 20, 25. So at 4, it crosses if we take it out to 4. And in general, exponential growth curve is going to look like this. You should become very familiar with these two curves. They're very important nowadays, especially with COVID. COVID spreads exponentially, not linearly, which is what makes outbreaks so important to catch early on. You see, if you don't catch this curve early on, it just gets steeper and steeper over time. Versus something that spreads linearly, which is a more gradual increase. So we don't have to calculate what's going on way the heck out here. We already know that the blue line is going to be way over the green line. And that's basically what you would write. I'm not going to write out the words for you. I'm going to leave that for you. But this is a fairly straightforward problem. And it covers the two most popular sequences, arithmetic and geometric. So that's it for today. I'll see you again next time.